Hey guys, it's Mrs. Jensen, and we've had a couple questions about using the calculator to do these sinusoidal models with the application problems. So I'm just picking up right where Miss Gamble is in the middle of her problem that she's doing on the video that you have for this lesson on the Ferris wheel. So we talked about there's a Ferris wheel at the Georgia Fair with a radius of 33.2 feet, and it does a revolution every 15 seconds. And remember, the Ferris wheel is 4 feet above the ground. So we wrote our equation. I'll go ahead and put that right here. So we already have our equation figured out, negative 33.2 cosine of 2 pi over 15 t plus 37.2. So now the key is, how do I enter all that in my calculator? So just a couple of reminders when you start to use your calculator. First, you want to make sure that your calculator is in radian mode. So if you click down here, you should have it selected. Just highlight that radian that should be darkened and hit enter. If it's on degree mode, it will be kind of screwed up. So you want to make sure it's on radian mode. You can hit second quit to get out of there. And then to enter our equation, we're going to click on y equals. And then in this case, it was a negative 33.2 cosine. And then we had 2 second pi over 15. And then in my equation on the paper, I'm going to use t, but here I'm just going to use x because it really doesn't matter. And then plus 37.2. Okay, so now my graph is in the y1, and it will show up when I graph it. So a couple of things. You want to make sure all your stat plots are turned off. Those are probably off unless you're in a statistics class. When you go to graph it, if it doesn't show up nice and pretty like this, what you might need to do is change some of your Windows settings. So first you can click on zoom, and if you go all the way down to 0 or 10, at the bottom here, it will be zoom fit. And if I click on that, the calculator will pick what it considers to be the best display for this graph. Well, in this case, it's an application problem, and I'm working with a Ferris wheel where time is my x-axis. So I might want to adjust my Windows setting here, and so I can start my minimum x value much closer to 1. I like to start it just a little bit negative so that I can see that y-axis really clearly. And then I can also adjust the maximum. So in this case, I'm talking about seconds. Maybe I want to see, it could be as much as 60 seconds. How many rotations would I do in 1 minute? That kind of thing. The third one down, x scale, that's how much the graph is incremented, my little tick marks along the x-axis. And so in this problem, I'm making 1 revolution every 15 seconds. So I could make this every 7.5 if I wanted to. So the y values, the calculator adjusted pretty well for me. So I'm not going to worry too much about those, except for that I might want to show the y value, the minimum, possibly at 0, just to give us a little bit better picture here. Let's try to graph that. Okay, so now I'm showing multiple revolutions of this Ferris wheel because I know that since this is a cosine graph, from the initial point where time is 0 until time equals 15 is 1 period. So depending on what the problem is, you might want to adjust your Windows settings differently. One of the questions I was asked next it wants me to figure out how far above the ground the passenger is 52 seconds into the ride. So I'm looking for my y value when x is 52 seconds. So there's a couple ways you can do this. Since I've entered my equation into y1, one of the easiest ways, I think, is to click on alpha F4, and your calculator should have these little alpha keys programmed. If not, you might be able to update your operating system from the TI-84 website. It's just kind of an added feature since the older models. But anyway, you want to think of this as being like f of x. And so you're basically saying my function, y1, evaluated at 52 seconds into the ride. So I'm putting f of x, or evaluate this function when x equals 52, or technically t equals 52 seconds. And so it gives me my answer back, 69.6745. So I'm going to round to 3 decimal places, so 69.675. If my x value, or t value in this case, were smaller, then I might want to use the table function. Click on second graph, which brings up the table, and then I can scroll down here with my x values, and I'd have to scroll all the way down to 52. So to me, that just takes a little bit longer, but it's definitely doable, and I should get the same exact answer. So if it were a smaller number here, like x equals 5, this would be a pretty fast way to get my answer as well. Okay, and then the last part of the question says, to determine the number of seconds the passenger has been on the ride when he first reaches a height, that's keyword first, because they're going to reach that height multiple times, first reaches a height of 27 feet. So in this case, I think one of the easiest ways to do that is go ahead and put in the line that is your y value. So y equals 27. And then when I graph that, I'll see that red line is just the equation y equals 27. So what I want to do to find the first place, the first time that the passenger reaches a height of 27 feet, I want to find where these two equations intersect. And I can do that by clicking on second trace, which is calculate, and go down to number 5 here. And I want to use my arrow keys to get back to closer to where that first intersection is. So I really want it to be over here, so that it'll say first curve, and just click anywhere on that blue curve. Second curve is the red one. Click enter, and then it always says guess. Just click enter. And then it gives me the point of intersection. So it says x equals 3.004, y equals 27. So after approximately 3 seconds on this super fast, speedy Ferris wheel that we're working with here, the passenger will reach a height of 27 feet. So that answers the questions in the problem that we're doing. Just to give you a couple other calculator features that may come up, we could also say find the maximum or find the minimum. And in this case, it would be a relative maximum, relative minimum within a certain domain. So we might say calculate, and then use number 3 or number 4. So if I wanted to find the minimum y value between, say, after 3.6 minutes, and then use my arrow key to go over and set a right boundary after I want to go past that minimum there, right? So I want to go past this lowest point, and I'm trying to figure out the x and the y value of that that minimum location. So just as we would expect, my x value, or my time in this case, should be right at 15 because I'm doing one complete rotation in 15 seconds, and my y value is 4. So we should know that without having to use the calculator function. So let's just add one little challenge problem here, since we're talking about calculators and what they can do to help us figure things out. So let's say as a challenge problem, we have actually 2 Ferris wheels. We have the first one we just did, and then you're on that first one, and we've labeled that equation f of t. And then the second Ferris wheel has a radius of 50 feet and makes 1 revolution every minute. The base of the second Ferris wheel is 6 feet above the ground. The equation for the Ferris wheel is labeled g of t. Now remember, if we're going to compare these two things, we have to have the same units for our input variable. So we need to use seconds instead of minute. But so if your friend is on the other Ferris wheel, you want to wave to your friend as you're on your way down. So you've already passed the height, the maximum height, and you're starting to come around the other side. But your friend is still on the way up. At what time and what height will you and your friend be at the same height? So I'll go ahead and I'll enter that second equation in my calculator. And I might need to adjust my window settings a little bit. So let's see. I've adjusted them to I made my maximum x value 60. I might need to make my y maximum a little bit higher because the other Ferris wheel is a lot taller. So if I want them both to show up here, it still isn't going to show the highest point of my second Ferris wheel. So if I want to find where my time and my height are the same after the blue graph, the first graph has reached its peak, I can just go to my calc function and go to intersect. And again, I'm going to have to highlight the right part of the graph. So let me use so I'm looking for, I'm going to highlight just to the left of where those two graphs intersect. And then this. And then that tells me the intersection. So after 11.161 seconds, right about 11.161 seconds, my height would be 38.436 feet above the ground. And if I'm on the first Ferris wheel coming down, my friend would be at that exact same height on the second Ferris wheel coming up. So notice that even just what we have in this window right now, we actually have 4 different points of intersection. So we have right when we're starting here, we have the second part when the first Ferris wheel would be coming down, I'm going up. The next intersection would be when the bigger Ferris wheel is coming down and the initial one's going up. And then lastly, we're both going down over here. So depending on how the problem's worded, we could find out a lot of information from the graph alone. So hope that's helpful. This is probably more information than you actually need to know for the basic worksheets, but just wanted to throw that out there as kind of more of a challenge problem. So hope that helps. Thanks.